Hello, welcome to the Indian Institute of Chemistry Student Corner. Our today's question is mainly about organic chemistry. So, without further wasting our time, let us get to the question and solve it. Okay? The question is that a tetrahydrofuran with an adjacent OH in its second position and a COOH group, CH to COOH group in its third position is being hydrolyzed in presence of acid. So what will be the product of this reaction? See, here 4 oxygens are present. So this is a type questions where in a molecule it will be given with a multiple number of oxygen atoms. And you have to find out the oxygen atoms which is more prone or more capable of forming a coordinate bond with a H plus ion. Here you will see that this oxygen atom is bonded to a carbon and a hydrogen. Here this oxygen atom is bonded to 2 carbon atoms which are both sp3 hybridized. Here you will see a carbon atom which is bonded to an oxygen. Here the oxygen atom is bonded to a carbon via a double bond, and this oxygen is bonded to a carbon which is sp2 hybridized and a hydrogen atom. Okay, so this is a type question. Multiple oxygen atoms which are capable of forming a coordinate bond with hydrogen. In this molecule, only this oxygen atoms which is bonded to 2 other carbons with sp3 hybridization. sp3 hybridization means it has a tendency to give plus I effect to its adjacent elements. Okay, here the adjacents are carbon, oxygen and oxygen. Here the adjacents are oxygen and carbon. So it can donate electrons via the plus I effect, which in turn increases the electron density much more on this oxygen than on this oxygen, because this oxygen is getting the electron via the plus I effect from only 1 carbon, and this oxygen is getting electron via plus I effect from 2 carbons. Okay, so in the resulting form you will get a molecule like this. A coordinate bond will form between this oxygen and the H plus. Okay, you will see here that oxygen is having a positive charge and hydrogen is getting its positive charge neutralized. Why is it happening? Because hydrogen get neutralized if it gets a 2 H plus is always an atom devoid of 1 electron. So it is getting an electron from this oxygen, and the other electron is not towards hydrogen to that extent. So this coordinate bond formation is just like a single bond between oxygen and hydrogen. Okay, and this oxygen, as it donates an electron much more to hydrogen, and which is away from the nucleus of oxygen, so oxygen is now devoid of an electron. So that is why it is getting a positive charge of unit value. Okay, so after that you will see here that a positive charge on oxygen makes an oxygen much more unstable. This instability has to be removed by this oxygen. So what will it do? It will try to abstract electrons from its adjacent elements. Adjacent elements means the carbons with which it is bonded to. Because it has already given electron to hydrogen, it will be very much unfair for this oxygen to take electron away from hydrogen again. Okay, so this will try to take electron from this adjacent carbons. Either it will take electron from this or it will take electron from this. While discussing about this electron abstraction from adjacent carbons, this oxygen tells this carbon to give electron to this hydrogen. Why? Because both are oxygens, and one oxygen is getting frustrated by seeing the other oxygen getting a positive charge. See how cool they are. They can understand each other pain. So what will it do? It will tell this carbon that I am giving my electron. Okay, I am giving one of my electron. I will form a new bond with you. You just give the electron to this oxygen. Okay, now what has happened? Now this oxygen is donated its electron to this carbon, is now having a positive charge. Okay, and this oxygen atom got neutral. Now this oxygen atom is telling this oxygen atom, you have got a positive charge right now. What will it do? he says, don't worry about me. I will just release this hydrogen and give it back to this medium, because H plus, this H plus has came from the medium, so I will give the medium back H plus. We don't take the favor from anyone. If I take something, I will give back something. So like that, it will release this H plus from here, and what you will get, you will get a molecule like this. Okay, it is very simple. I think you have understood up to here. Now this H plus is again floating in this medium. Okay, the H plus is again floating in this medium and trying to take a position of its own. Now this molecule, as here you can see that here is a OH, here is a OH, here is a double bond O, here is a C double bond O, and an interesting fact is that the distance between this OH, 1, 2, 3, 4, 5, and this carboxylic group is 5. Okay, this OH group and this COOH group can now react with each other. Okay, this OH group having a lone pair of electron will attack this center because it is in close proximity, and it is very much easy for this OH group to attack this COOH group. Okay, so this will lead to the formation of a 5-membered ring like this. Okay, here one position will be occupied by this oxygen, and here C double bond O, it will hit this, so it will form a CO minus, and here it will be an OH. Okay, C double bond O minus and a OH, and here see 1, 2, 3, the third position. Here from 1, 2, 3, in the third position you will have CH2 and CHO, CH2 and CHO. Okay, you will have this one. Now the hydrogen which has been released here will be taken up by this one and will lead to the formation of this compound. Okay, this is aldehyde. Here this comes like this, one OH, another OH, and this one. Now as two OH groups cannot stay in a single carbon atom, okay, this is a formation of what? This is just like a gem diol. Okay, this is just like a gem diol. Okay, so what will happen here? This two OH group will leave and water and will tend to form and cyclic lactone like this. Okay, this is what will happen in this total mechanism. So this will be the final product of this reaction. Okay.